Here is a question from radical equations and extraneous roots. So first, I do notice that this expression here is power to the 1/2. So you may feel like this is a little bit new, like what does this 1/2 mean? So I'm going to rewrite it in a way that looks a little bit more familiar. So I can represent a fraction of an exponent. So the power to the 1/2 is the same thing as square root of 4x minus 4. So we're like, okay. So if I want to remove this square root, I do eventually want to power it to the 2, but I don't want to power it to the 2 right now, because you'll notice that it also gets this 4, but I only want everything inside the square root. So first thing I'm going to do is subtract 4 to both sides, so that all I have on the right side is the square root of 4x minus 4. So everything is under the radical, and then everything else is on the left side. So now what I can do is I can power this to the 2 on the right side and the left side. The moment I have an exponent to the 2, this eliminates the radical. So now I have x minus 4 to the power of 2 is equal to 4x minus 4. Although it is possible to power the right and the left, there is a condition. The moment you put an exponent on the right side and on the left side, we must check our work after we get our solutions. So after we obtain our solution. So I'm just gonna put a star there so we remember. And then I'm going to continue. So from here, you may notice that we have an x on the left side and on the right side. But in order for me to solve for x, I need to isolate x. So let's first make it our goal to get this x out of this parenthesis. So we have x minus 4 to the power of 2, so let's factor that out. So we have x minus 4 times x minus 4 equals 4x minus 4. Then you might notice, I can use distributive properties. I'm going to distribute it, x squared minus 4x, and then use distributive property again. Negative 4x plus 16 equals 4x minus 4. I'm going to combine like terms, so it's x squared minus 8x plus 16 equals 4x minus 4. Alrighty, so now I'm going to combine all the like terms I can. So I do see that I have negative 8x here and 4x. I also see that I have 16, a constant. So it's a term without a variable, and I also have negative 4. So I want to combine the like terms. So let's first get this 4x and subtract it so that it goes towards the left. So I have x squared minus 12x plus 16 is equal to negative 4. And then I'm going to get rid of the negative 4, so it moves to the left side. So I have plus 4 plus 4. So I have x squared minus 12x plus 20 is equal to 0. Alrighty, so I combined all I could, and from here we have two choices to solve for x. So first choice is what we learned in class, factoring. Or here's a second choice. It's something called the quadratic formula. It's really up to you how you want to do this. For this particular example, since we went over factoring in class, I'll show you factoring. So I'm going to factor this quadratic. I know to get x squared, I need x and an x. And then from here, I need to think of two numbers where when we multiply, so I need to think of two numbers, when we multiply it equals to 20, and when we add the two numbers, we want it to equal negative 12. Okay. So you can kind of think about that. You can pause the video right now and see if you could think of what these two numbers are. I'm going to let you know that it is negative 10 and negative 2. So if I multiply, I get 20. And if I get negative 10 and negative 2, and if I get the sum, I get negative 12. So I can put negative 10 and negative 2, and it equals to 0. I'm going to erase this so that I have a little bit of room. Then from here, you'll notice this expression multiplied by this expression is equal to 0, which means when one of these expressions is equal to 0, then the whole equation becomes 0. So I'm going to say, what if x minus 10 is equal to 0? Or what if x minus 2 is equal to 0? And we're going to consider both answers. So I'm going to solve for the one on the left side first, isolate x, so add 10 to both sides, and I get x is equal to 10. On the right side, I add 2, get x is equal to 2. So you might feel like, yay, I got the answer, celebrate. However, I do want to go back to the star, the note I left myself. Because we did an exponent of 2 to both sides, we have to consider, are both of these solutions really true for the original equation? So it might be true for the equation that we created here, but we want to take it way back to the original equation to check. So let's first plug in 10, and then we can plug in 2. I'm going to just, I'm going to get the one in green because I feel like the radical symbol is something we're more familiar with. So I'm going to just bring this straight down here, and then we're going to check it. So let's first substitute 10. So instead of x, I'm going to put 10 is equal to 4 plus square root of 4 times 10 minus 4. So it's 10 is equal to 4 plus square root of 40 minus 4. 10 equals 4 plus 36. 10 equals 4 plus 6. 10 equals to 10. So this is a true statement. So we can say that x plus 10 is definitely one of our solutions. And then now we're going to check x is equal to 2. So let me just choose a different color. Let's go with green. So this time, from this equation, every time I see x, I'm going to replace it with 2. So it's 2 is equal to 4 plus square root of 4 times 2 minus 4. 2 is equal to 4 plus square root of 8 minus 4. 2 is equal to 4 plus square root of 4. 2 is equal to 4 plus 2. 2 is equal to 6. Well, 2 is not equal to 6, right? So this is false. So because when we check it, x equals 2, although we obtained it as a potential answer, once we go back and check it, you'll realize, oh, it doesn't make sense according to our original equation. Thus, x equals 2 here, this is an extraneous solution. It means a solution that doesn't work. So our final answer would be the x equals 10 that we obtained and we verified. So as my final answer, I'm just going to put at the way bottom, x equals 10 is the solution, and x equals 2 is an extraneous solution. So the only real answer we have is that one, x is equal to 10.